Now in this video we'll see the configuration of SSM. Now SSM, if you want to configure source specific multicast, we just need to enable SSM feature on all the routers. So we need to specify the range, like we need to say IPPIM SSM default, and if I don't define the range, by default it's going to enable the SSM feature for all the class D addresses which starts with 232. Now if you want to enable SSM feature for specific range, we can still write an ACL, and in that ACL we can define the set of addresses, and whatever the addresses you define, it's going to only build stored S, G entries for that particular addresses, whichever matches the ACLs. But right now I'm not going to define any specific ACLs here, which means it's going to build the S, G entries for all the addresses whichever starts with 232. And if any router is sending some star G entries for this particular group, whatever I defined here, it's going to simply drop. So no shade tree will be built here for this specific group. Now the next thing, we need to configure PIM SSM enable on the interface wherever we have something called, so on the interface where we have some receivers, we need to enable IGMP version 3. Because the previous versions, version 1, version 2, they do not support SSM features. So they just support the previous, whatever the previous implementations we have seen, and the default version is version 2. Now if you want to have a receiver who wants to build the S, G entry direct to the source, instead of using an RP in between, we must run version 3 on the interface where you have a receivers here. And that's what we are going to do here. We are going to say IP IGMP version 3. So if I don't define the version, the default version is version 2. And then we need to define, just this is something, we are using IP IGMP join group command for this multicast group and the source. Now this command is going to tell that there is a receiver here who wants to receive the multicast traffic for this particular group address, and it's expecting that from a specific source, so that it can send the join message direct to the source, which is on router 1 here, the loopback 0 interface. You don't see the diagram, but it's pre-configured in my labs. It's going to send some join messages. Now this is a more way of simulating a host who wants to receive the multicast traffic from that particular group. Now probably in the real scenarios we are not going to use this command. Now you will have a receiver here connected which is already enabled with some application, and that application knows exactly from where it should receive the multicast traffic for that particular group. Now here we are just simulating the host, saying that I got a host or a receiver who wants to receive the multicast traffic from this group based on this source address. So it's just a way of simulating a host receiving the multicast traffic. Now apart from that, the prerequisite configurations are same. All the routers are pre-configured with OSPF here as per the diagram here. If I just get into the basic configurations, all the routers are pre-configured with area 0, and we have all the interfaces are pre-configured with IPPIM sparse mode. And the third thing, we are going to enable SSM for the default range, whatever you see the configurations on this slide here. So let's go here and verify the prerequisite for this lab. Now the first thing, we must have IPPIM enable. If you verify show IPPIM neighbors, and if you verify the configurations by using show run include PIM, you should see all the interfaces are enabled with IPPIM sparse mode, and there is no RP configurations. So I was having some RP configurations based on my previous labs, I removed them. Now all the interfaces are just enabled with IPPIM sparse mode, and IGP is also pre-configured here. Now I want to enable SSM on these routers, on all the routers. We need to say IPPIM SSM, and I'm going to use a question mark here. Either I can say the default range. When I say default, it's going to enable the SSM and build some S, G entries for all the addresses whichever starts with 232. That's what I'm going to use here. Or based on your requirement, we can even define the range, and in that ACL we are going to define for what are the multicast addresses used for SSM, and based on that we can define that what are the group addresses should form S, G entries based on SSM feature. So I'm going to use just default option. Default option is going to enable for all the addresses whichever starts with 232 in the first portion with /8 mask. Now once you enable this, let me enable the same thing on all the routers. So the same command we need to configure on all the routers. Let's go to router 3 and then on the router 4 as well, and on the router 5. Now once we configure SSM default on all the routers, well, now I'm going to simulate some receiver here who wants to receive the multicast traffic from specific group, and that group is the source is 11.001, which is somewhere on the router 1, the loopback 0 interface. I already have pre-configured loopback over there, and then it's going to be 232.5.5.5. Now to simulate the host, we need to configure the commands. If you remember, we need to enable on the router 5 interface F0 by 0. I'm going to say IP-IGMP version 3. So the default version is version 2. So if you want to enable a receivers to send some join messages direct to the source instead of RP, that particular interface must be enabled with version 3. And then we are going to simulate some host where we are saying that it should join to this group, and it's coming from the source. The source address is 11.001. Now that 11.001 is on the router 1. So if you verify on the router 1, I got a pre-configured loopback interface with 11.001. Now before we go ahead with this configuration, just make sure that particular 11.loopback interface must be reachable via IGP. So I'm going to advertise that. I didn't advertise that, and that interface also must be enabled with IPPIM sparse mode as well. Okay, so let me do that. I didn't do that, I think so. So if you verify show IP interface, show IP OSP of interface brief. Now let us go to the interface loopback 0, and I'm going to say IPPIM sparse mode, and then I'm going to advertise that 11.loopback interface with a /24 subnet mask. In fact, it can be /32 as well. Done. Now just ensure that you have a receiver, that is router 5. We should have a reachability to that particular source address because we are about to send the join message to the source. Now it's going to check the reachability to that particular source, 11.001. You can see I have reachability. Now to further go and verify, I'm going to simulate the router 1, and I'm going to send the multicast traffic for 232.5.5.5, and then I'm going to send it via source 11.001. Now I should have reachability from the router 1, which is acting as my server, which is sending the multicast traffic from this source address and for this group address. You can see the replies coming, and if I go and check on the remaining routers, 232.5.5.5, I should see an entries coming here. Now let's go and check on the router 4. On the router 4, you can see the source S,G entries, and you'll see the input interface is S1 by 1. That's S1 by 1 is your this one. It's coming from this interface, and the output interface is S1 by 2. It's sending out of this interface. And you can see there is a S,G entries built automatically, and there is no *G entries here. And there is no need for the RP here. Without any configuration of RP, we are still able to reach from the source to receiver. And the reason is simple here. Whenever you simulate the host or send the multicast traffic, it's going to send some join message directly to the source, because the receiver knows exactly where is the source based on the IGP path. And then your multicast traffic is sent. So the next thing, we have some specific other show commands also we can use, like show IP IGMP, show IGMP, show IGMP, show IP IGMP join group, and then show IP IGMP, and then we can say groups 232.5.5.5. If I say detail option, probably I should use that command on the router 5. Let me verify show IP IGMP groups 232.5.5.5 detail. Now you can see the group address. There is an interface on F0 by 0, which is using SSM feature here. And the next thing is, if you verify show IP mroute on the remaining routers, you should see S comma G entries for that particular multicast group address, and the source is 11.001. Now the major advantage we get with this SSM is there is no need for the RP where the receiver is going to send the join message direct to the source and is going to build the S comma G entries directly. It's going to build the shortest path to that particular source from the receiver, and it really avoids the need for the RP here. And one thing we need to keep in mind that the receiver must be enabled, the first hop router from the receiver must be enabled with version 3, and the application running on that particular receiver side, it must know about the source, and that application must be aware of the source. So that's the only requirement you need to have, and the configuration goes very simple here.